124 light-years from Earth, an alien world glides silently around a dim red sun in the constellation Leo. This is K2-18b, a planet roughly 8.5 times as massive as our own, wrapped in a thick atmosphere of hydrogen gas. Beneath those heavy clouds, planetary scientists believe something extraordinary exists, a global ocean of liquid water, spanning an entire world without a single island of dry rock. It is neither a rocky Earth nor a gaseous Neptune, but a completely alien category of planet known as a Hycean world. In 2023, when humanity aimed its most powerful space telescope toward this distant orb, the light passing through its sky revealed something even more staggering: chemical signatures that, on Earth, are produced exclusively by living organisms. K2-18b was first spotted in 2015 by NASA's Kepler Space Telescope during its extended K2 mission. Astronomers were scanning thousands of faint stars when they noticed a periodic dip in light from an M-type red dwarf star, catalogued as K2-18. Every 33 days, the star's brightness dimmed by a fraction of a percent as an unseen body crossed directly in front of its glowing stellar disk. From that brief transit, scientists calculated the planet's vital statistics: a diameter 2.6 times that of Earth and a mass 8.6 times greater. Situated just 16 million kilometers from its host star, less than 12% of the distance between Earth and the Sun, K2-18b occupies the star's circumstellar habitable zone. Because its primary sun is a cool red dwarf with a surface temperature of roughly 3500 Kelvin, the planet receives an energy flux similar to what Earth receives from our Sun. If you were to stand atop a vessel floating in its upper atmosphere, the dim red sun would loom immense and dark red in a deep pink sky, casting a warm maroon light over a horizon that curves away far more rapidly than Earth's. Understanding the true nature of K2-18b required looking beyond its size and distance. In 2019, data from the Hubble Space Telescope revealed water vapor in the planet's atmosphere, sparking intense debate. Was K2-18b a mini Neptune with a crushing, superheated interior of dense gas, or was it something entirely new? Nikku Madhusudhan and his team at the University of Cambridge proposed a revolutionary concept: the Hycean world. They theorized that a sub-Neptune exoplanet could harbor a massive liquid water ocean beneath a relatively light, hydrogen-rich atmosphere, provided the atmospheric pressure and heat budget were precisely balanced. To test this hypothesis, astronomers turned the James Webb Space Telescope toward K2-18b in late 2022. Using Webb's near-infrared spectrograph and near-infrared imager and slitless spectrograph, they analyzed the starlight filtering through the planet's atmospheric fringe during a transit. The resulting transmission spectrum yielded a definitive chemical fingerprint. Webb detected abundant carbon dioxide and methane, while showing a distinct absence of ammonia. This specific chemical combination is crucial. In a purely gaseous world devoid of a liquid surface, chemical reactions at high temperatures and pressures would naturally generate high concentrations of ammonia. The lack of ammonia suggests that atmospheric gases are dissolving into a vast liquid ocean beneath, which strips the upper air of nitrogen compounds. The atmospheric pressure at the base of this hydrogen sky is estimated to be tens of atmospheres, enough to crush a deep-sea submersible if it descended too far, yet calm enough near the ocean's surface to permit liquid water to persist at temperatures around 0 degrees Celsius. Your body would weigh more than twice as much on K2-18b due to its higher surface gravity. If you fell into its ocean, the sheer weight of the atmosphere above would press down on you with immense force, while the crushing gravity pulled you down into dark water thousands of kilometers deep. The ocean itself may not possess a solid ocean floor of silicate rock like Earth's seas. Instead, beneath hundreds of kilometers of warm, dense water, the immense internal pressures likely freeze the liquid into exotic high-pressure ice phases, such as Ice 10 or Ice 11, creating a crystalline barrier between the ocean and the planet's molten core. Yet the most tantalizing revelation from the James Webb Space Telescope was a subtle spectral signature that science did not expect. The spectrum showed tentative evidence of a molecule called dimethyl sulfide, or DMS. On Earth, dimethyl sulfide is not produced by volcanic outgassing, lightning, or abiotic chemistry. It is generated almost entirely by living marine organisms, specifically microscopic phytoplankton drifting in terrestrial oceans. If the detection of dimethyl sulfide on K2-18b is confirmed, it would represent the first potential biosignature ever detected on an exoplanet. However, astrophysicists remain deeply cautious. The signal detected by Webb was faint, bordering on the edge of statistical significance. Computer simulations also show that the intense ultraviolet radiation from K2-18, a red dwarf prone to magnetic flares, might drive unknown photochemical reactions in hydrogen atmospheres that could mimic the spectral signature of DMS without any biological activity. Researchers are currently acquiring additional observation time with Webb to verify whether this biological ghost molecule is real or a statistical anomaly. K2-18b forces us to rethink the boundaries of life and the cosmos. For decades, the search for habitable worlds focused exclusively on Earth analogs, rocky planets with thin nitrogen skies orbiting sun-like stars. But red dwarfs make up more than 70% of all stars in the Milky Way, and subneptunes are far more common than Earth-sized worlds. If Hycean planets can truly support liquid oceans and living ecosystems, then habitable environments may not be rare oases in a cosmic desert, but vast, water-draped worlds scattered across almost every star system in our galaxy. Everything you have ever known about life may be merely one brief chapter in a much larger story.